Thank you very much. Grazie, Ken. Thank you for the tweets on the volcanoes. Since yesterday, Ken actually announced me the volcano morning, etc., etc. But I've been tweeted on the volcano objective. Why not? It's fine to me. But no volcanoes today, otherwise I would have been talking about the natural resources, and instead it is the A&D day. I think that yesterday when we were starting discussing about the industry solution portfolio, why as well the Dassault system being in the experience economy and wanting, if you wanted to offer differentiating, if you want a type of solution, the decision of calling industry solution experience was not just by hasard, as a French would say, but it was done on purpose. Now, the point is that for consumer goods, it's so easy to speak about experience management. It is so easy to imagine as a consumers, what does it mean having an experience in Starbucks, having an experience in a fashion company, having an experience in CPG, having an experience in high tech, as we saw in Apple. What the hell is the experience in aerospace and defense? Isn't it tough? It is not, actually. So this morning, you will see something that is pretty interesting. In this chart, actually, you see the whole portfolio that was developed for aerospace and defense. There are fantasy names, but there are fantasy names that actually capture the value that we want to bring to the market. When we look at aerospace and defense, for sure, we have the different segment. For sure, we have the distinction between the manufacturer and the supplier to aerospace and defense and the client of aerospace and defense, which means that when we analyze what are the key values that we want to bring and capture in our portfolio, we need to think at three different dimensions. We have the manufacturer value, we have the operator value, we have the passenger value that we need to take into account when we create the industry solution. So with this different naming, if you want, in just one chart, you have all the things and the end benefit that we can bring to aerospace and defense industry in every single aspect. From winning product to co-design to target to virtual rollout, you can actually reconstruct the whole life cycle captured by values depending on who you are into the system or the ecosystem of aerospace and defense. If I take the first example that we are going to see in a few seconds, which is winning program. Winning program is the very beginning, if you want, of the ideation of a program, which means that is the conceptual phase. Who's the target, and therefore who's the customer actually for this type of solution, are those that needs to win programs. Who are they? They are aerospace and defense providers that needs to be awarded with a program. So the real value for those that are into this business is not really to construct the aircraft. It is first of all to bid to win. And that is the value that the winning product actually capture. And you will see how this becomes an experience, not just because it's Dassault system and delivering an experience to those guys, but as well those companies actually needs to deliver the experience of which is the best conceptual phase, configuration, and even trade studies actually that needs to be conducted in order to be awarded with a program. That's all I wanted to say. I would like now to invite on stage the Vice President of Aerospace and Defense for Dassault Systèmes Industries, Mr. Michel Tellier. Thank you.
Thank you, Monica. Good morning. Today I'm going to walk you through a demo of what we've done with Winning Program. And as Monica said, the focus that we took here was really how to drive the competitiveness that you can bring into the development of your program, how you present it to your customer, and how you optimize it. So that's the focus that we brought. I've got with me Fabien Roger, who will be running the demonstration. And so we're going to start off right away. And again, this is a fully live demo, but it's the work that we've been doing with Winning Program. So let's say, for the purposes of the demo, we're DroneWorks 3DS. That's our company. We make drones, small drones. And let's say I've got the highly enviable job of being in charge of product development from an ideation standpoint. In other words, bid acquisition, program acquisition, project acquisition. So, as we talked yesterday, the 3D Experience platform really is not just an engineering platform, it's also a business platform, and it covers the end-to-end process. So if I'm in this kind of role, the first thing I want to be able to look at is fundamentally, what are my key KPIs? What are the key things that I use to make business decisions and track that work? So you know, this is a sample dashboard. We saw some dashboards yesterday. This is the same kind of approach. And if I look at the overall market size, you know, I can see it based on different segments, from commercial through industrial through military. On the upper left side, I can see what my market share is. Of course, I'm going to be wanting to look at, you know, where the market is growing, which segment is growing faster than which other segment, what my potential market share is in each of those segments, and where my portfolio is distributed. In this case, I'm going to look at the industry sector. Okay, so what are we doing for drones? What are the drones that we kind of build for industry, and where is that market going? And here we've broken it down to the subsegments such as agriculture, energy, and the different sub-areas, as well as different classes of drones, whether they be rotorcraft or aircraft or light aircraft. If I dive into the energy sector in terms of a market opportunity and a positioning, we can look at it from a geographic perspective. I can look at, for instance, what's happening in that segment from a drone perspective, where that market is going. I can look at where are my customers, and certainly, of course, I want to see where I am versus the competition. So, you know, very quick overview of the kind of topology that you'd want to wake up to every morning if you're running this kind of business, because that's what you're ultimately trying to do. Figure out where the market is going, what you have to do to get there, what your competition's doing, and what are the specific segments, subsegments, and regions where the opportunity lies. More on the geek side, we have the portfolio. So what you're seeing here is the two aircraft on the left are my existing portfolio, or let's say DroneWorks 3DS's existing portfolio. And the timeline at the top is just program gate, so they're both in production, and they're both in full production. The concept we're looking at now is the one in orange. And to be specific, we're saying we're going to go after the energy sector, because right now it's being operated mostly by manned helicopters, and there's an opportunity to replace at least field inspection and activities like that with unmanned aircraft. And so we're going to look at the development of that aircraft. So fundamentally, all the data that you saw is not artifacted. It comes from somewhere. So I'm going to explain to you how that data is created, because that's the really interesting part. And that's where the competitive pressure really comes to bear. So here what you're looking at is I'm developing this new drone for this segment. What are the key KPIs for that mission? In other words, what are the key mission parameters that I have to focus on? Of course, the typical ones show up: range, which is the big box, you know, my configuration family, payload, and of course the amount of reuse that I'm doing out of my existing asset base from a technology standpoint. And each dot corresponds to a different concept. So in other words, I'm looking at multiple different configurations to meet this aircraft mission. Okay? And essentially what you're doing at this phase is the more alternatives, the more investigations, the more trade studies, and the more thoroughly you can perform those trade studies are the drivers that allow you to make the best possible decisions. Not just in terms of performance, but also in terms of producibility and operability. So here what we've done is we've defined a sample mission. So you're looking at a part of the planet, and you've got that little red ring there. That's the mission profile. It's much more defined than that. It's essentially an offshore wind farm that is actually there. And what we're doing is that for all of our concepts, we're virtually flight testing them. Some of them every day, some of them every night, but we're virtually flight testing every single concept on all of the mission profiles that our different customers in the different markets that we're going after may present to us. Why? Because that's what's going to drive the most information to us to be able to take decisions. So as you can see here, we're tracking different parameters. Now, if I'm looking at one configuration, I obviously want to be able to compare it with all the other configurations I'm looking at. So in other words, fixed wing or rotor lift and so on and so forth. Here I took a long range variant, and I'm able to compare and contrast all the different parameters for each configuration or each concept versus each other. So it's a very powerful decision support tool. Right? And here, you know, we have 5 parameters, but, you know, I have a customer that's tracking right now over 12,000 parameters in terms of their virtual flight testing. So this is the simple view. And really the objective is to try to make sense of all of the data that we're generating. Put another way, the opportunity to virtually flight test all your missions on all your concepts and on all your derivatives daily generates an impressive amount of information that needs to be wafted through. So how is that virtual flight testing possible? should be the next parameter that we have to address. And what we're doing here is we're using the CATIA systems platform. And we've defined and are defining all of our concepts in the systems-based language, in other words, the logical definition of this particular aircraft, okay? And so you can see where Fabien is pointing that, you can define the actual mission. So in there we have teams that map and define all the different mission profiles. We have a definition of this concept. So if I break down into the functional decomposition of this particular aircraft concept, I'm going to go into the, in fact, flight guidance and data acquisition function. And there you can look at, fundamentally how that is authored. And what we use is a Modelica language, which is an open standard language, which is very ergonomic to model all the different behaviors of that system. Also importantly, it's got FMI interfaces, so if you're not using Modelica, you can use whatever language your engineers are already using, and it can still map into this and couple into this, which is very important. Now, we've got the definition, we've got the modeling definition, we've got the behavior, but if you want a flight test, you also need to manage the other parameters, such as aerodynamics. So we've coupled in the whole CFD, or computational fluid dynamic, and flight and aerodynamic laws into the equation, so we simulate that as well. So essentially here you've got mission definition, vehicle definition, and then aerodynamic behavior, or multi-physics properties, that we're all combining to perform what we call virtual flight testing. So, another way of looking at this is if we take a specific function, we can define through the application all the different stages of the life cycle and all the different stages of maturity they can take. In this case, it's interesting because we've taken the requirements, the system will hash them, break them up into usable components so they can be tracked into the functional concepts. And so for those who are not, let's say, fully in the industry, yeah, for aerospace, it's extremely important that all the requirements that denote a mission be carried through the entire life cycle, and that we both hash them, consume them, and evaluate, what the risk of them coming to bear and their means of compliance and their means of certification. So that traceability from requirements for us is extremely critical. In this case, we look at the definition of an existing component for air data capture. And this is actually in a different language. This is in Simulink. So I'm just showing you very casually that it's not critical to rip out everybody's tools to make this happen. This is a layer that sits above the detailed definition of the systems and allows you to map in existing systems with systems under development at different stages into the same simulation. So if you're saying, Mitch, that's great, wonderful demo, but that won't work in the real world because I've got different systems at different stages of development. Some stuff I already have, it's off the shelf, and my engineers are not going to use your stuff day one. They're going to continue using the tools and the assets that we have. This can accommodate that, which is very critical because the value we're adding is being able to integrate all those systems. Fundamentally, it's a virtual Iron Bird that is activated on day one and that maintains its operation through day 1,000. As that virtual Iron Bird is no longer virtual and actually becomes physical, or an actual aircraft. And of course, I want to track for this particular component or this particular configuration, its evolution. I'm not just trading, I'm also optimizing. So here I'm tracking, of course, its progress on weight and its progress on cost, or should cost, which are the two things that we usually track at this stage from a progression standpoint. And of course, I track that against where we are in the different program. So that is an overview of the technology that we're using to create these virtual Iron Birds, and it's not an artifact. Look at it as the collaborative platform that's simulatable for the whole advanced design phase and conceptual design phase. So once you've done that, you obviously want to be able to present what you're actually doing. So the presentation layer, or if you will, the experience of understanding it is quite important. So here we've mashed up a bunch of stuff. And this is all live. It's not a pre-canned video or anything. This is all happening live. So here you're watching the actual mathematical multi-physics representation of that definition we saw with the flight laws and all the different system parameters in action in the upper right-hand window. You see the flight profile on the left. Actually used here an off-the-shelf software for actually piloting drones. So we just integrated that into the thing. And in fact, when we were at Farnborough this year, we had We had a joystick there, for the pilots in the room could actually fly the bird and do what they wanted with it. So it is a full fidelity definition. And as you can see here, it is on its mission profile. It's being simulated above. If we go on the ship, where the control station is, part of our deliverable is also a control station. So of course, that is part of the design. I mean, for all intents and purposes, this is actually the pilot experience, right? This is where they program the craft. This is where they define the automation for the flight profile. And Fabien is even manipulating the camera on the aircraft, and you see that manipulation in the screen. So it is a living, breathing, fully functional behavioral machine. And it is, again, not an artifact. It's a development process. And so right now we have the drone loitering. So this particular drone, just to make it fun, we made the rear rotors actuable so it can go in thrust versus lift mode, and a couple different behaviors with activated, or active, if you will, flight control and damping. And so what Fabien is showing us now is essentially, we slowed down the demo because we're going sub-real time now in terms of the simulation. And for the thousands of different parameters we can track, I mean, we can follow signal strength, signal intensity, motor drive, all the different stresses and loads against the simulations that we're running. And here Fabien pulled up the power profile for the different motors on the drone. So what we're doing is, as you can see, the different motors, the 4 different motors are all cycling because it is hovering, so it's trying to maintain its stability. And then when it resumes normal flight, they'll harmonize again, and the bird will fly off. So essentially, you're looking at here live the simulation of the 4 engines controlling the flight and controlling the behavior. So we're gonna probably swing those engines and glide off in a second. But that gives you a sense of the overall, if you will, control and stability of the simulation. And so the idea behind this is to create a collaborative definition where all of your different engineers that are working on all your different concepts can measure their ideas, and you can trade off the different concepts dynamically. You can base that information not on estimates, but on actual multi-physics simulation of how all those things fit together. You can do that on top of their existing tools, which is extremely critical. And then you can use that information to what we call accelerate the maturation of the design. In other words, all of the work that you've done to optimize the designs, all of the decisions you've made, and everything you've pushed to make that happen, you can trade off through this process. And we think that's a very, very powerful capability. I mean, the opportunity to investigate thousands of different concepts, approaches, optimize reuse, or optimize against whatever parameters you think will drive the decision is critical. And when it comes time to convince your customer that your concept is the best one, this is a very powerful argument. I mean, this demonstrates that every piece of homework you possibly could have done has been done, and that's what drives the confidence that you probably have the winning program and the best proposal. And fundamentally, that's what we're trying to drive to in terms of this overall experience, is to provide you with a very powerful competitive weapon to not only ensure that you win the program, but that you've done all the work necessary to deliver it at the end of the day, and we think that's what makes the biggest difference. So with that, I hope you enjoyed the demonstration, and thank you very much.